Okay, so here's some cool stuff that we can just mess around with right now. Um, Here's a propeller. Yay! And you can have propellers in as in different connecting. This one connects onto a motor, so you could connect them maybe to a gear or something. And this motor doesn't produce much power because it's a brushless DC. So if I turn this on, as you can see, it's pretty. So what's happening actually is that the air is going behind me. So I'll turn this off. Now I've got a piece of paper, but really I think the best thing would actually be smoke or like a vapor. If you got like a vaporizer, I think that's what they use for aerodynamic studies. So if I turn this on and I put it here, you can see it's not really doing anything. Oops, it's getting short-circuited. One second. But if I put it behind, look at that. Oh, actually, no, it's still not really doing anything. Well, whatever. I'll turn it up a bit. And, oh, it's kind of pushing it back, but not really. Still not really. Now, if I flip... What I did was I flipped the lead, so the positive connector I had to a certain wire, I connected to the opposite wire. Essentially what happens is you can run the motor backwards and it just, instead of going clockwise, it'll go anti-clockwise, or anti-clockwise, it'll go clockwise. It seems to push air forward more so. It's pretty small. Oh, actually, there we go, turn it up a bit. And you can see there, there it is pushing the tissue. I guess you can kind of see it. There we go. Now if I move it, if I move it around, it really starts doing that. And I'll turn it up. I'll kind of like max it out a little bit. There we go. And you can probably hear it. Oops, did I just blow it up? No, I just. Oh, geez, I just. Okay, I think I managed to fix this. So unfortunately, these motors are a little bit flimsy. So I know it's terrible. I know, don't worry about that. But here I reconnected it because it was just barely a tiny little bit of metal. I just have to be really careful with that. Anyway, whatever. So point being is that one direction of the motor makes it go forward, the other one makes it go backwards. Oh, that's really going. Yeah, it's sucking. You can see it. It's pulling it in. Isn't that cool? Otherwise, here it's pushing it back. Wanna? It well, okay. Whoops. That was not meant to happen. So here's something interesting. When I turn it on, this is getting kind of hot, actually. So this is, I'm running it pretty heavy, at about 30 milliamps, right? And if I put one of these propellers on and turn on, oh, jeez, what's it? The voltage drops, which is interesting, but the speed of this goes down. So the speed of the motor is now currently slower, and the voltage is kind of related to the speed of it. The amperage seems to be related to the power of it. If I put this other one on, yeah, same thing. Now, interestingly, if I put something heavier, like this giant cog kind of wheel looking thing on, it goes fairly slow. Like I could touch it and the voltage is way down. If I turn the amperage up, it'll then go, be stronger and quicker. But then if I take this off, see, amperage goes down. So the amperage is kind of what does the heavy lifting, and the voltage seems to be the speed, at least for this DC motor, because of course with AC motors, usually your speed is dependent on your frequency, I believe. So you change the frequency of the AC power, and then the speed changes. But the point being with these little motors, and mind you, these things do not have a lot of torque. It's just a little motor. Now it's good for a fan. Make a little like a handheld fan, right? Of course, you want some more safety features in that. Like you want to put in like cage or something, because otherwise you don't want it, touching you or just pop, coming off and being like a Beyblade of death. Oh yeah, I've got this giant one. I wasn't able to print it properly, but I've got some of it, so I'll show you what it looks like. You could use these little ones for their speed, and of course, assuming it's not moving anything too large. But otherwise, these do not have much torque. You really need a big motor for torque. And torque is like strength. Yeah, look at that. Sounds cool. I do not really want to touch it. It's going kind of quick, right? And I'll turn it down. So if I turn it down a lot, I'll slowly turn it up. Now what happens if I touch it is it'll stop it, because it doesn't have the strength, which is a torque, right? It'll start, I can stop it. Oh. I then played around with gears, right? This is a little I'll show you. I just 3D printed a stand. I didn't get the supports out. Don't mind that. And here is a propeller with like a wheel on it, right? A gear. Excuse me. It's a gear, and the gear. It's not perfect, I don't think. I'm still trying to figure out how to perfectly, move gears and all that stuff. So it's a little bit locked. And then I've got this one here with the hole. And what we can do is, I'll show you. We put this in here, and then we can, what it works is it kind of goes around like that. So my idea was if I had a big gear, because if you have a big one attached to a small gear, if this spins around fairly quick, this will spin around really, really fast, right? If I take this off, so that spins, right? This is all because it doesn't have enough strength or torque. My sounds of these sound tons. Just to get it, you can like see that's fairly smooth, right? That's pretty. There's a couple. So what you do is you turn it around until turn it around until you feel there's like or you do this, and you'll feel. This one's actually too good. It works too well. Usually there'd be like it'd be locked like that. You see that? And that's actually just brushing against the propeller, but it'd be like locked. And then you take it out, and then you sand whatever gears are around here. One other thing, these look like funnels. And what they are, you can make them yourself, or you can just get a funnel, I guess, or an object that looks like this. If you blow through the small hole, air will come out there, right? It's like a big spray of air, like a cone of air. But if you blow through this big hole, and it'll go through the small hole, it's like a lance or a spear of air, right? But what happens is that it's kind of compressed. It's compressing in the tube, and it's a little bit compressed, but then it starts to go bigger and bigger and bigger and bigger, right? So air, I don't know how, I mean, maybe like you can compress air with a magnetic field or something. I mean, technically it would be like a force field, wouldn't it? But otherwise, if air is not contained it doesn't stay compressed for long, but at least you do get a little bit of a jet, like an air jet. So I guess this is, if you sprayed water through one of these things, and this one's tiny, it's really hard to, you get like a tiny little thing of air, right? So it's not very, not great. But anyway, these are just like to play around. You can play around to understand air. So just like blow through this side, that side, and just think about like how, it's a big area, you can blow lots of air, but then it's a tiny area, or it's a tiny area, but you can't blow much, but then it spreads out. So all these kinds of things. Same thing with different types of propellers. This is a generic propeller, so it's for blowing air forwards and backwards. This one seems to blow it around the sides, right? So that's the purpose of this one. And I've got another one, which is curved. You can see it's curved, right? It's kind of cool. And the point, this is like, I was trying to replicate an air blower. What I can actually do, I'll show you. This whole thing's broken, by the way, basically, so do excuse it. That's why I got all the tape on it and all that stuff. But I've actually, it's because I got to make the central piece a little stronger. I'm still working out the kinks of this kind of stuff. If I plug this in and try to get it, oop, I think I might have just, yes. All right, there we go. So that's kind of cool, yeah. Ooh. Grab the motor and oops, that's not. It's not very strong, so it's, you know, turn up. That. And if you blow on this, it makes a cool sound. And it spins around. It's really cool. I'll fix this up and make it better, and I'll give the 3D printing file so you can make one of these yourself, because they are really fun. It's just to blow on, I don't know. Yeah, so it's like a this is pretty much, it's similar to like a car's turbocharger actually. It's got that like central turbine, and also similar to a leaf blower, because this essentially, you are plugging a motor into it and you're just blowing out air. And of course, if I optimize this more, it would blow lots of air. So you could, you know, if I make it like, or even if I just made it bigger, it would blow more, you know, volume of air, right? Okay, so this is, these are 2 gears. Let me see if I can get them off on a board. There we go. So I started experimenting with gears. This one is a 32 tooth gear, right? And it's nearly like 40 mil. I think it's like 37 or something. I don't know, because I you know, shrunk it a little bit, I guess. And they fit nicely, right? And you can move them, and it's really cool, right? I think that's really nifty. One cool thing is that this gear turns counterclockwise when you turn this one clockwise. You can see. And if I turn this clockwise, this one goes counterclockwise. So they're opposites. If you want a gear here turning the same way as that one, you have to have three of them in a row. Okay. And of course, gears to the same size are really easy to work with. There's all kinds of gears. You can get ones that like spin them like this way, right? Actually, I think these ones will just work that way if I made them a little bit, yeah, maybe if I made it like a touch longer, or even I think if I had it really close, it would work. And then you can get ones that are like that way. There's all kinds of crazy ass like gears, right? They're fun to play around with. I'll show you how to make them later on. I spent like 2 hours trying to make this, and it doesn't really work. It kind of works. See, it's really not so great. Now the problem is, I think the gears are too long, or maybe my size is wrong. I don't know. If this was in like an industrial use case, it would be a bit better. But yeah, I tried to make like a thing to push it in, like kind of like square pegs, and it doesn't really, like, it works, but it doesn't. I would have to glue this in if I wanted to. So that's how that was made. This I'll show you later maybe, but it's got like a little tiny thing, like a little tiny square, so So here's what that looks like. You can see it's got that, and then you can see I've got these little blocks on the rod, so that way it kind of locks it in. Yeah, it kind of stays in. It doesn't, even if I move it, and it's really tight. I had to hammer this in. Actually, it's super tight. Otherwise, yeah, this top gear looks kind of cool, doesn't it? The bottom gear, it's kind of hard to see, or if maybe I can, actually, yeah, that's pretty loose. As you can see, it's just a tiny, tiny little, really just, if I did this like a bunch, eventually it would like wear it in, right? It would just grind it down. All right, so if we're in Blender, what we want to do, firstly, make turbines, because making turbines and gears is pretty much the same thing, or it's very similar. You just add a cylinder, and you want to go down here in the add cylinder thinger, and the vertices is very important, because the vertices will pick on how many. See, if I turn it down, it turns to a triangle, then it goes like a polygon, right, and it becomes more advanced. You see these faces here, these individual faces, is how many turbine blades you're going to have, for example. Now, of course, you can make turbines in different ways. You can just make a high resolution cylinder, for example, and then we can add another thing. We'll add a piece of paper, right? You can either use a piece of paper, or you can add a what do you call it, like a block, or really whatever you want. But you can, excuse me, you can specifically craft the turbine out of this, for example. Like, we can just go down here, and we can just do that, and then we can go down here, and you can rotate this. Example 90 degrees. Yeah, we can do about 9, or so we could do 90 if you want it that way, or we can do like 45 if we want it that way, right? And we'll make it a bit bigger, make it like, you know, put it in the center, make it a bit, you can make it the size of the whole thing like that if you want, or you can make it a bit smaller, right? And that's kind of a turbine thingo, and then of course we can solidify that turbine blade to solidify, and then give it some width, for example, maybe a bit more, and then you've got a turbine, and then all you do is you just copy paste, just take this one, and oh jeez, it hasn't. Copy, paste, there we go. This, and then just drag it down, right? And then you make sure it's proper. So wherever that one is, that's 1, 2, 3, 4, 5, 6, 7, and we just have 1, 2, 3, 4, 5, 6, 7, right? And we also want to rotate, or do we want to rotate it the opposite way? I actually don't know. Maybe we do. If we do, because then I'd have to go there. Yeah, probably, I think so. Just rotate it the opposite way. Hang on 1 second. See where that little point is there? We have to go to Objects, Set Origin to Geometry, and that centers it. That's good. And then just rotate it on the y-axis. We go -90. And there you go. See, that's 2 on the opposite side. Then all you need to do is just copy them both, paste it again, and then you just rotate these. Actually, no, let me get that. Let me central it again. For some reason, I don't know why that's messing up. Whatever. Set origin to geometry. Yeah, that should be fine. Just copy them both, and then just rotate them 90 degrees, and now see that's starting to look like a turbine. And we just copy it again. How many more do you need? 4. You need 4 of them, so just copy, paste, and same thing, rotate 90. It's not centered properly, so just there we go. 45, that should be it. And of course you're going to have to fix things up. But really that is all you need to do. And then, you know, if you want to make these more complicated, for example, you can go in the edit and you can start chopping it like that, and then you can like do that, you know, so it's a little more angled, and you can do all kinds of stuff to like edit it, right? So for gears, they said it's the same thing. You just go cylinder, we want 32, and then edit mode, and of course select all. Actually, I'm going to shrink that just because it's a bit too tall. Back to faces, and select every second. And then again, same thing, E, we're wrong, wait no, is it R? Wait no, it's E to extend, for some reason it's picking a direction, and S to extend it out. And we don't want these too big. And then what I do, I don't know how to select them all at once, but I just do click them and then do S to shrink. And I shrink, I'll look at, see up here it has scale, on the top scale X and Y. And I'll do about 65. See, that looks, oh, maybe about 60 actually. That's a bit too much, about 60. I'm looking on the top left kind of area. And then I just do, you know, 60. So here we are, that's like a really simple gear. Another thing you do is you can select the top face and you go I and see this thing, and the same thing. It doesn't seem to do it on both. If I do it on both, oh wait, no, I can do it on both. Okay, so for example, if I want to make, if I want to, you know, simplify the gear or make it so it's less weight to it, I could do that as a barrier, and then I could do this as like a central hole, and then just so this center of the gear is going to be 1, 2, that's about 5. I think around 6 to 8 mils, kind of nice. Anything below 4 mils, like a bit too small. So I'm going to actually just, hang on. I'm going to like make this a little bit, oops, for some reason it's, I think it's like shrunk it. I'm going to stop it. I'm going to get rid of that. Maybe go back to vertices or something like that. Oh yeah, whatever, good enough, right? And I think we can do what do we do, like a dissolve, delete vertices or something? I don't know, you can do stuff like that and then just connect all of these, you know, do the connect new edge kind of thing, right? So to like make a whole, that's, otherwise you just use a boolean. It's probably easier to use the boolean modifier, which is that you add another cylinder and you put the cylinder here as the object, and that's a negative. But otherwise, like what I did is I think I selected both these, and I did I do delete face? No, I did bridge face. Here we go. And that created a hole there. So you can do that, or you can use the Boolean modifier to create different like internal shapes, so you don't have as much you create more negative space to make it quicker to print and also lighter. So, you know, if you have a motor, it doesn't have to work as hard. Of course, if you want it heavier and bigger, it acts as like a flywheel, and you don't want to do that. But just an example. And usually the ratio is, so this is 16 teeth or 32 faces, right? One that's half that, so 8 teeth would be half as big, right? And I still, as we showed, my gears kind of lock up and they're not that great, but I don't know, something like, I think it's something kind of like that. I'm still trying to figure out how to get it working properly, but and usually they are the same height, so it's just different. And I'm trying to figure out, like, should some teeth be larger and smaller, or I don't know. I'll figure that out. But that's pretty much the basics on how to model these things. You probably know what I'm talking about now, or how to do it. Okay, so if anyone wants one of these things, swear it sounds cooler in real life. I don't know if you noticed, but my mic seems to be screwing up while picking the sound up. I'll show you the internals. So it's 3 major parts. It's this part here, as you can see, which has got all the pegs. This part has all of the holes, and then we have the turbine. And what you do is you just go. You got to do it a certain way. I forget which. So just test out both, and you might need to. I've shrunk the central. I've shrunk the central peg. To be a bit smaller, but I had to sand it, and I had to put some like grease or like wax or like butter on it, right, to get it to spin well. So you might have to do that, but as I said, I did shrink it in the model, so it might, and then you just attach it, and it should snap together. Again, same thing. If it doesn't snap there, then you have an issue. And seems to I think it's grinding against the sides, so you have to get it quick enough. But anyway, otherwise you can edit this. What I could actually do is make a peg with a block, so that locks it in, and then have like a hole or a gear coming out, so then you can attach that to a motor, and then it'll act as an air blower. So if you want it, I'll attach it in I will show you. Okay, so here you can see I've just done the layer height as 0.3. Printing in PLA, so it's PLA plus actually, but PLA should work, or pretty much any of them should work. Pretty standard settings. It's not a very complicated print. Okay, if you want a copy of that little air blower thing, just go to my website, go to download, video downloads, and right here in November, just click this hot link here, air blower toy 3D print files, free 3D printable air turbine toy. Of course, if you want anything else from the video, comment and I'll upload it, that's fine. Or you can experiment and practice making your own stuff. Anyway, of course, to have a good day and goodbye.